Okay, guys, so welcome to the Robotics and Artificial Intelligence Meetup number 48. This is the last session about humanoid robots, and last week and last week we talked about Atlas robot, and we covered how the parkour and dance mechanisms might be and the algorithms underlying it. And the first session was just exploring humanoid robots in general. And so today we have with us Pranchu Tople. I think a lot of people already know Pranchu. He is the director and co-founder of Rig Beetle Labs, and he has been associated with robotics since quite a long time. And the project that he will be sharing today is building a humanoid robot from scratch. This robot is called Disha, right? If I'm not wrong.
Yes,
Uh,
yes, it is.
yeah, so it would be a pretty interesting thing because now that we have seen how you know the now we have seen case studies of the existing robots in the market. We can see how you can start to do such projects on your own, and it also is cost effective, right? Because he used mannequins and all the available electronics that you can find in your nearby stores, let's say. So I'm pretty excited for this session, and I'll just tell about today's agenda. So after this introductory presentation, we'll have just the topic presentation, which will be followed by a discussion. And so, Pranchu, you can keep it either way. Either if you want to have just a presentation strictly for 30 minutes and then followed by discussion,
Mhm.
or mix. So, yeah, feel free to go about that the way you want to. And then after
Yeah,
that, we can have short introductions very quickly, and then casual networking before we
yeah,
wind up. And
sure. So,
yeah, just very briefly about the community again.
mhm.
So we are an active learning group of robotics and AI enthusiasts, and now we decided that we would be taking up a theme for each month, which we have been doing for the last, I don't know, 6 7 months already. And everyone can actually participate regardless of whether you are experienced it or with robotics or not. And you can also volunteer to share your own projects, and if you want to, you can check the Meetup volunteer or paper reading volunteer channels on the server. And the meetings will be recorded and shared online. So if you want, if you have if you don't want, let's say, your personal introductions to be shared, you can just tell me about it and I'll edit that out. So that's not a problem. And there are some other roles that you can check in the assigned roles channel. But okay, yeah, let's just start. That's it from my side. And now Pranchu, over to you to
Yeah,
share your
give me a
project.
moment. I'm just making my computer ready for the presentation. Just a minute.
Okay,
Yeah,
yeah, sure, sure.
until then we can have introduction about other people who are there on the call. So I want to know what kind of crowd do we have? Do we have students? Do we have working professionals?
Okay,
Uh,
perfect. Yeah, yeah.
yeah.
Meanwhile, while you're making it ready, we can have a
Mhm.
short introduction. So I think most of the others have already been here in quite regularly. So let's start with Sidhuji. I think he's new. Can you briefly introduce yourself, Sidhuji?
Hello.
Hi.
Yes.
Hi, I'm Siddhant. I actually know Pranshu sir from there was an event. I don't remember right now, but there was a hackathon contest type where we needed to design a UI for a robot waiter. So I was the finalist at that, and I have also done the Ross mentorship program at Reed Beetle Labs recently.
Oh, that's nice. That's nice. Yeah, welcome,
Yeah,
Siddhant. Welcome to the server. Yeah,
yeah,
so Siddhant is actually from your server. So and
Yes.
Shore, yeah, Shore has also been joining recently. So can you also introduce yourself briefly?
like uh, I'm an undergraduate mechanical engineer right now, and currently I'm doing my final year BTech project in soft robotics.
In soft robotics. Okay, and what kind of project are you doing there?
So, I am designing and researching about a pneumatic gripper. So,
Huh.
proper simulating that thing and doing the analysis part and that thing.
Okay, so you're focusing on actually, so you're also fabricating the materials also, or just taking up existing stuff and refining the design. So is it more of a materials related project, or more you're optimizing the design structure? Like what exactly are you doing?
Like it is more of designing kind of like project.
Okay, okay, okay. Cool, yeah, that's cool. Soft
Yeah.
robotics project, yeah. Okay, and Manjot,
Yeah.
so maybe you can also briefly again introduce yourself.
So I am Manjot Singh, and I am a third year undergraduate, mechatronics branch, and I am interested in mobile robotics and also humanoids. But I have worked um, in projects related to mobile robotics.
Okay,
So
perfect, yeah.
yeah.
Nice, thanks for joining again, Manjot. And Krish, I mean, I hate to say it again because you, but you have to introduce yourself again.
Yeah, so hi, this is Krish here, and I am currently in my final year of high school, which is 12th in India, and I'm probably moving to college next year.
Hmm.
So, thanks.
But see, Krish, your introductions are also changing, right, as you're progressing with your studies and everything. So it's not
Uh,
monotonous. Yeah. Okay.
Yeah.
Cool. Yeah. So Lucas just joined. Lucas, could you briefly introduce yourself? We were having introductions before we start with the topic.
Yeah, hi. What shall I introduce? Lucas here, lives in Germany. I work in a specific field of automation and logistic, doing now my second master in embedded system, focused on industrial field and building automation system. My work of field is more with PLCs and control and automation. And I
Okay.
have done some focus in visual systems also.
Yeah. Perfect. Thanks. Thanks again, Lucas. Welcome. Yeah, Yuan. Again, and so I have to ask you to briefly introduce yourself again.
Okay. Hello guys. Well, I am a mechanical engineer, and right now I'm doing my master's in robotics, and it also has a specialization in automation, industry automation. And yeah, yeah, uh, happy to be here.
Okay, perfect. And you are in Spain still, or you're moving? You moved to some other place. You're still in Spain, right?
Yeah, I am doing the master in Spain. Yeah.
Okay, okay, okay. Perfect. Yeah. So last is Jidnyasa, and then we can start.
Hi, I'm Jitnasa. I'm a final year computer engineering student. I'm interested in robotics and I have basic knowledge of ROS, and now I'm trying to dig deep into it and do some projects. Thank
Okay,
you.
Mhm.
perfect. Thanks, Jidnyasa. Okay, so Pranshu, whenever
Yes.
you're ready, we can
Yeah,
start with
yeah.
it.
We can do it now. I will just share my screen. Just give me a moment.
Okay.
Yeah, my voice is clear, right? Is there any background
Yeah,
noise
it's
or anything?
perfect. No, no, it's good. It's good.
Mhm. Okay, just give me. Here we go. So yeah. So before starting with the presentation, as Sandeep said, we like I am the co-founder and director of Rigbital Labs. So I would like to tell you what Rigbital Labs actually is. And before even before going towards that, I would like to say I don't have a presentation because I have been traveling currently with for some work purposes, so my schedule is really hectic. But I wanted to contribute to this humanoid robots related thing. So the reason I came over here was I in my final year, like in the 4 years of engineering, I worked on a humanoid robot, and that was presented as my final year project in my undergrad degree. And that is the reason I wanted to share it with you so that you can take the work forward. So currently, I founded Rigbital Labs, which is a service-based company. We make robots which comes into the agricultural robots, warehouse robots, commercial robots for other companies. So we provide consultation in hardware and software related things. Apart from that, currently we were growing our team in India, and that is when we came across to people who were not very much aware of Ross. So what we did was we started a education vertical as well in under Rigbital Labs. So if you go to the website of Rigbital Labs, just a minute, rigbitallabs.com. My screen is visible, right?
Yeah, yeah, yeah.
Yeah. So if you go to rigbitallabs.com, sorry for the slow Wi-Fi connection. I am at the hotel. So just a minute. Yeah.
Pranshu, I can also just share my screen and you can tell
Yeah,
me and
yeah.
I
There,
can.
there. Yeah, yeah.
Okay.
Fine. So yes. So as the website shows, like we are unboxing the future tech for you. So we work into software application, mobile application, robots, virtual reality, and augmented reality. So these are some branches in which we work, and we have clients nationally as well as internationally. And when we were growing our team, we found out that students were not aware of this kind of things. So what we did was we started with a playground, which was a free service where students can book an appointment. So here I can choose a date, I can choose a time, and I can just fill up the info and I can book an appointment for a controlling a ROS based robot. So this is what we did. So if you want to know more about this, what you can do is you can go to YouTube and just search my name over there. You will get a couple of videos. So this is my channel. So here if you go, I have shared one video about 7 months ago. So here I can show you we made a ROS based robot, and it is a free platform that anyone can use at any time. You can directly control the ROS based robot. You can visualize the sensor data. You can visualize live frame feed from the camera of the robot. So here you can see. So here you can see there is a live feed from the robot, what robot is seeing. This is the arena, and you can navigate around and you can do all ROS related things. Uh, so here, if you want to try it out, you can try it for free. And later on, people wanted to learn these things, these kind of things. So we started with mentorship programs. So currently, we are running various mentorship programs under which we teach students as well as working professionals about robot operating system, about quadruped robots, about legged robots and stuff like that. So I will just show you. Yeah, if you just go to repeaterlabs.com/mentorship. I don't know what's bad with the internet connection. There you go. Yeah, Chandeep, can you share it on your end?
Yeah, sure. I was actually just doing
Yeah,
that.
I
Okay. Yeah, so it's rigbeetlelabs.com
uh,
slash membership.
mentorship.
Ah, okay, sorry. Mentorship.
Yeah, yes. Yeah, there you go. So we have online mentorship programs for students and working professionals. So here are a couple of them where you can see we teach about robot arm, AR, VR, ROS 101. So can you click on know more in ROS 101? Just scroll it back. Yeah, you can just click it and scroll it like that.
I'm not able to scroll
Yeah.
to the left
Okay.
side.
Yeah, just a minute. Yes. Click it once again. Same. Yeah, once again. Okay.
Uh,
Fine. It will come at the end, I guess. That is
Just
Ross tool.
left click and scroll towards right.
Yeah,
okay,
there you
okay,
are. Yeah.
okay, okay. It's a recursive. Okay.
Yes. Click on the no more button. Yeah.
So
Yes.
Ross mentorship
So
program.
yeah. So Siddhant has been part of this. Uh, you can scroll down. So here you can see what is ROS, why we use ROS. So the ROS is the fundamental thing that we use in all industrial robots. That is the reason I have been promoting it very widely. So if you scroll down even further, you can see we have a complete curriculum about like where is ROS used. Scroll even further. You can scroll down. There is a curriculum page where you will see what you will be taught. And how is it different from any other online course? Because all the sessions are live sessions. It is not like a Udemy or Coursera course where we will be giving you free videos. There will be an industrial mentor in front of you who will be guiding you personally. So if you have any doubts, you can check out over there. So that is what we do. And then even further, you can go. Yeah. So you will be taught to design robots, develop robots, simulate it, and even if you go further, you will be learning about simultaneous localization and mapping, autonomous navigation on all these stuff. So the reason I'm showing you all these because the humanoid robot that I'm going to show you right now, it has the guts of this ROS. So the ROS is the soul of this robot. So that is the reason I am showing you all of these things. Um, and we do have international students. We have like um, almost 100 plus students are graduated from Ross mentorship program right now. And we have students from Germany, we have students from Mexico, Brazil, and a lot more countries. Yeah. So yeah, if you are interested learning about Ross, you can check out over here. So now let's get to yeah, and there are a couple of FAQs as well. You can go and check it out. So yeah, you can
Okay.
get back over here and I can show. Yeah.
Okay, perfect. Yeah, I'll share the link also in the chat
Mhm.
room.
Yes.
So I've shared the link now.
Yeah.
So yeah, I think personally also this is a really good thing that you're doing because it's structured way of
Mhm.
learning ROS, and with ROS, of course there's ROS wiki, but it can get really challenging, especially if you are doing your own project to
Yes.
understand it and implement it in a simpler way. So I would recommend this thing as well.
Yeah.
Yeah.
Thanks. So yeah, so you guys can come back to my screen sharing. Yeah. So when I was of most of your age, like when I was in my bachelor's degree, when we were in first year, it's around the year 2017. It was summer vacation, so we didn't wanted to go home because once we go home, it was very tiring. There was no productive work that we can do. So what we did was we took up a challenge where we could build a humanoid robot. That is what we thought of. And while thinking of the robot, we thought of a lot of things like how could it walk, what all things it can do. And at that moment of time, Facebook was the only social media platform. So we thought, why not to share our journey on Facebook? So we started with a very basic design. We took some steel pipes and we started welding them together in a shape of octagon. So you might think why exactly octagon? So I have a design of my robot soon. I will show over here. I guess it is in the next post. Oh my god, the internet is really laggy here. Just a moment. I'm sorry guys for the uh, lag, but please bear with me.
No
Yeah,
problem, no problem.
yeah. So this was the design of the robot. So what we thought was we were not able, like we were first year engineering students. We were not that experienced in making things walk or making things do some particular thing. So what we did was we made this base design where it would be controlled by wheels and motors. And the wheel we chose was omni wheel so that it can move in all directions. But we thought we cannot make a robot that can walk. So having a base would look a little bit ugly. So what we decided was let's make it a girl. So in we can if we make it a girl like robot, we can hide everything inside a skirt. So that is why we chose this octagonal design, and I will show you all the progress one by one that we shared on this page that we made. Yeah. So we started with welding the structure. That was even didn't had any CAD models ready by then. We just drew it on a paper and we started doing it. And as this was hip, so it was more elliptical rather than a proper regular octagon. And it was a regular octagon at the bottom. So this is how we started. After that, uh, we bought a mannequin, and what we did was we attached the mannequin on top of it. So this like on the day one itself we had some basic structure ready for the robot, but now the real challenge began after this, which is to move it. So how could we move it? So we added some brackets, again some metal brackets we designed our own, and then we added motors to it. So here we were adding supports for the motors, and once it was done, we painted it just to make it clear. And then here we had, so we added four single channel motor drivers, some motors which could carry a weight around 20 kgs, and we didn't had wheels available by then, so we just waited, and this was the photo that we took at a very initial stage. So we were almost ready to make a humanoid robot. And this was a time when Sophia was not there, okay, guys. Sophia was released in the October of 2017. We had nothing to refer to. This was all coming from scratch. So what we did was we added a Arduino Mega to control all these motor drivers, and this was controlled by a Bluetooth module. So we can control it using a simple smartphone. So that is what we thought for the initial design. And once we had motors, we were not even patient enough to make a stable chassis. So we just used a thermocol that was laying around and we started moving the robot. But effects, what happened was we blew up all the four motor drivers. How did it happen? Because the current that was taken by the motors was not were above the peak limit of this motor driver. So this is where we learned, okay, we have to analyze things properly. We have to test how much current it draws, and then we have to choose components. So we were like first year students. We didn't had any idea about all these things, but it had it affected our pocket, and that is how we learned. But later on, we were successfully able to at least move the robot. So here you can see it is moving, and as it had omni wheels, so it could move in any direction. There was no limitations. So just like humans can walk sideways, similarly this robot could also walk sideways. So when we thought of yeah, this could walk sideways. So what we thought was we thought an application around it, which was to make it like a dancing robot. So if you, I have a video of it on my Instagram as well. Uh, if it loads on time, yeah, here we go. Mm, yeah. So as it could go sideways, so here you can see first it's moving backwards, then side. So this was another one of my teammate, along with we were just adding some dancing functions to the robot. So coming back to the thing, so we were we are very tight on our budgets. So we used wood, MDF, and all these kind of things. There was no expensive 3D printing or anything because 3D printing was not common by then. Later on, here in the back you can see we added high torque motors, which was low RPM, so it was just 10 RPM, but it was enough because we had enough torque. We attached servo motors, we attached some MDF blocks for shoulder. So we just ripped apart the complete mannequin and we were using it as we wanted. We even ordered some high ampere. So here you can see 30 ampere peak motor driver for the wheels of the robot. So this is what we did. But when we ordered this robot, that time our wires burned off. So we understood even wires are responsible for carrying the current. So even wires should be powerful enough to carry the complete current that is going to the motors. So again, we learned one more mistake. We learned from one of our more mistakes, and then we upgraded our wires as well. So by the time the electronics team was working on that, we also worked on the arm. So here you can see we attached some servo motors at the top, again some wood brackets, then then two servo motors, one for twist of the arm, twist of the elbow, and one for the lifting of the elbow. And then again we had one more at the end for turning of wrist. And this is how we started making it. So don't get bored because the end of this complete robot is really interesting. Okay. So yeah. And by the time the team was working on this, we also started working on some kind of finger mechanism. So we started prototyping with simple foam board as and some strings. Yeah. So here was how we were adding all those things, like we were scratching metals and stuff. And we wanted to have feedback from the shoulder. And how could we have feedback? The encoder's motor were very costly at that time. So what we did was we attached a gear to the shaft of the motor, and we attached it another gear, and this gear what attached to a potentiometer. So now we could have a feedback from the potentiometer. So now this DC motor acted more like a servo, and we can control its angle like a servo motor. So this is how we attached it. And if we also added a panel at the back so that we can access it easily and we can open it. So once we open it, we had motor drivers for these two motors. We can have our electronics based over here. So that is what we did later on. And we were just focusing on the mechanical aspects for now. And this was when in the July we started more on the software thing. So we added voice control to it. So can you hear the voice of the video? Can you tell me?
No, Pranchu, for that you have to share stream and not screen. So currently you're sharing the screen.
Okay, just a minute. Share stream.
Yeah, and you have to then select only that particular window.
Okay, I can only see the share
Yeah,
screen
when you
option.
click on share your screen. Oh, sorry, it's called applications, right? So when you click
Yeah,
on
yeah.
application, you will see that window. When you select the particular window, then you can
Oh,
yeah,
okay,
share the audio as well.
okay. Can is it audible now?
Yeah, now it's audible. Yep.
Yeah, so I will. Yeah. So we added voice control. So in that, if we say a keyword, something like OK Google. So here we added Hey Disha. So she would say first it would ask for password. So she would ask for password and then she would act accordingly. So here, let's see it in action. She says password required. She says access granted and hello I'm ready, and she initializes all the relays. Now it's fully functional. So you can clearly see excitement on his face when she raises her hand. So yeah. So this was very initial stage. Okay, we were first engineering students. We didn't know anything about text to speech or anything such, but we were able to do all these things on our own without any guidance. So we just did whatever felt right, and we were just learning from the internet. So that is the reason I always say internet is your best teacher. And mm, this is when the Disha project ended on social media, but we made a video because by this time all our funds was exhausted. So this funds we took it from like the prize money that we won during our engineering days in different competitions. And that is when we started looking for some kind of investor, majorly our own college. So we proposed them a video. So I will show you that video. Just give me a moment. I have to share my screen again, I guess.
Yeah,
To
yeah.
yeah, I will start the video and then I will share the screen. And then this video is in voice of Disha. So just wait for it. Yeah.
It's me. Do you integrated se-
It's audible, right?
Yeah, it's audible.
Okay.
Hello, it's me. Do you integrated semi-humanoid android? Better known with the
But
name Trisha.
actually,
You saw me
we
last.
can't see the video moving. I can only see a fixed sort of a
Is it?
screen.
Is it?
Yeah, yeah.
Uh,
So actually,
Copy
what I know what the
instructions.
problem is. So what you have to do is, is it on the website you're opening, or where is it on Chrome? Where have
it
you?
is on a. It is on a. It's locally there.
Okay,
I'm
okay.
streaming it from.
Yeah. So you
Yeah.
have to select this particular window. Uh,
Okay. Just a minute. I guess it is on web as well. I will share it from there if it is
yeah, I think
playable.
that would be better. Yeah.
Yeah. I have it on my Google Drive, so I will share it from there.
Mhm. While Pranchu is sharing, I just want to mention one
Hmm.
point here, right? So a lot of people ask, I want to build this particular, I want to build a legged robot, I want to build this. How do I
Hmm.
start, right? And you see from this Pranchu's journey, we see that they just started it. They didn't really
Yeah,
spend too much
exactly.
time thinking about it. They just started it and then figured things out along the way. So yeah, I think this is the. Of course, you could keep it more structured, but it's once you start it, you can always organize the project more. Or what do you say, Pranchu?
Yeah, exactly. That is what I want to say. Like it's the most difficult thing is to start. Once you start, things fall into place properly, so you don't have to worry about it. But
Yeah, yeah,
at least you have to start.
yeah. I
Yeah.
agree with that.
Yes. And yeah, guys, like it is an interactive session. Okay, so if you have any questions at any certain point of time, just stop me and ask then and there. Okay. So yeah, there we go. I will start
Hello,
the
it's
video.
me. Do you integrated semi-humanoid android? Better known with the name Trisha.
Actually,
You
I'm
saw me last
not
year
able
at
to
the
see
induction
the
ceremony
video
doing
still. I
pretty
can hear
much
the
awesome
audio.
things. But now I want to be more than what I was before.
Is it still not visible? Yeah. Can you see it now?
Yeah, now it's good. Yeah.
Okay. I guess like whenever I do full screen, it's not visible.
Yeah, yeah.
Okay.
Exactly, exactly.
Trisha, you saw me last year at the induction ceremony doing pretty much awesome things. But now I want to be more than what I was before.
So these were some features like we added certain motions, we made it to dance and stuff like that.
And I'm sure I can achieve those heights with the help of my creators at Ajinka DY Patil University. My team is working on many more software and hardware updates for my second version, Disha 2.0, which can make me a better social interactive humanoid robot. Here are some of those.
So yeah, and one more thing I wanted to show you, like we were also working on an animatronic head. We thought of adding
Which
a
can make
emotion based
better social
face to
interactive humanoid.
emotion based face to Disha, something like this, but it didn't ever happen. But yeah, it's we made this face as an individual project. So yeah, even you can go with that because this individual face had almost 13 servo motors, and those 13 servo motors were controlled by an Arduino Uno. So yeah, if you want to control just an expressive face, you need an Arduino Uno by itself.
Robot. Here are some of those. I can detect a person and recognize those gestures. I can even recognize more than one person and categorize them differently. I can also track their skeletons to understand their body language. Thanks to computer vision, I can recognize people's faces and know whom I am talking to. I even detect their facial expressions to know how they are feeling. Not only people, but I can also recognize different objects in our surroundings like chair, motor cars, bottle, etc. I can also recognize different commercial logos and read texts.
What logo is that?
That is the Raspberry Pi logo.
What does that say?
That says TP-Link, the reliable choice.
I am also capable of seeing the world in 3 dimensions and also detects noise in 3D.
Hey Google, how are you?
I'm doing great. Thanks for asking. What can I help you with?
What can you do?
There are lots of things I can help you with. For example, you can say things like, define circumlocution.
This was all possible due to the Google Assistant API built into me, which makes me your personal assistant.
Where are we right now?
Your current location is Pune, Maharashtra.
Hey Google, tell me about Pune.
Here's some information about Pune. Pune is a sprawling city in the western Indian state of Maharashtra.
I can also be used in home automation.
Turn on the light. Turn off the light, please. Blink.
So here are a few things which we wish to implement in my next version. I hope your support will stay with us. Thank you.
Yeah, so this was something that we did for Disha 2.0. We proposed it to our college, and then they gave us permission, they gave us some grants, and that was how. And it completely took 4 years to make Disha 2.0. It had various functions, like as in the video you can see, it had a depth camera, so it could understand the environment, it could recognize objects, it could recognize person, and as we are adding depth camera, we also added autonomous navigation into it. And then our whole 4 years of engineering, we were completely working on this project day and night, just because we wanted to make a social interactive humanoid robot. So that is how everything fall into place. And now I would like to present the final what we say the thesis that we submitted for Disha. So even I have a presentation that I would like to show you guys. Mm, I will share the presentation. Yeah, can you see the presentation, guys?
Yeah.
Yeah. So just a minute. Yeah. So in the presentation, it was like in the 1950s, robots were only used in industries. It started there, the robotic revolution, where robots started to get into our daily lives, which is not the daily life, but daily life of an industry. And in 2019, they are still there, but they're still there only into industries. So they are not into our day-to-day lives. So why can't we see robots in our daily life? So the reason behind that is there are two reasons majorly. There are robots that can work in our day-to-day life, but they look like a little bit scary. Looks like if the robot hits you, you will be badly injured. And then there are robots who look okayish, but then they are not very much functional. Why? Because their hands don't move properly, they don't have enough payload capacity or stuff like that. So what we did was we made a combination of both. So like as you can see in 2 months, May to June 2017, we made Disha, and the name was Due Integrated Semi-Humanoid Android. So it it was running on an Arduino Duo. That was the reason the name was Duo, and it had integrated. So that is the thing. And semi-humanoid, because it was not a complete humanoid robot, it worked on wheels, so it was semi-humanoid. And android means a robot, a human-like robot. So that is when Disha came. The same video that I showed you right now. uh, yeah. So if we look at the body, so uh, we added all these different types of actuators. So in hip there will be a linear actuator so that it could bend. The complete frame was made of aluminium. There will be a shoulder rotates per gear with encoder. So this time we had a certain budget. So you can see we added encoder motors. And at the same time, all these gears were customly manufactured as 3D printing was available at that time. So you can see we started with very bare minimum things like uh, wood, plastic, foam board, and then we evolved into 3D printing and stuff like that. And later on, if we even go further,
Um, Pranchu, I can't hear you. I think it's might be a network issue from his end. Can you guys hear him?
for the thesis, we started 3D printing and made this frame out of aluminium. And then we 3D printed the complete arm. So instead of making out of wood and mannequin this time, the base was same because the base didn't even needed anything else. It was very good base. So just we 3D printed the arm. Yeah. And then you can see these are the different customly manufactured gears using 3D printing. Yeah. So we had some spur gear mechanism over here, some bevel gear mechanism in the shoulder. We attached direct servo motors in the elbow, and there were five small controlling the five fingers of the robot. Then we did the simulation because by this time we were introduced to ROS. We knew what ROS is and how we can simulate it. So we using Shacro, we made the URDF of the robot, and then we could able to visualize it in RVs. We could move each and every joint. We can make different poses using it, and using move it, we can also do inverse kinematics calculation. So if Disha knows there is a water bottle in front of her, she can navigate her hand at that exact point without any external control. So Disha was becoming smart at this point. So for control system, we used NVIDIA Jetson Nano. For controlling all the motors, we used a Tinsy microcontroller, and it was all running on ROS Kinetic, which was available at that time. And then this was demo. So do I have a demo video over here? No, I don't have it. So yeah. So future work, as I said, we were already working on this kind of animatronic robot. We made it as an individual project. So you can see the lips and mouth moving. It also had it all the eyes can move up, down, left, right. Even it could blink. And yeah, here you can see blink, and it can move its eyebrows. Again, even in that had text to speech capabilities, so it could people could talk to that animatronic head. And this was a video from the InMove robot. Also, we were thinking to make something similar, but it was all future. We didn't go till that. But yeah, the task that Disha was able to do was opening doors easily, turning knobs. That was very easy, recognizing people and different objects. It was based on computer vision, picking them up using inverse kinematics, autonomous navigation using ROS, general chatbot capabilities due to Google API, and some smart actions like if it doesn't recognize any person in a room, it would automatically close like switch off all the lights and fans in the room, because it had raspberry it had Jetson into it, so it could directly speak to the AWS server and switch on and switch off all the lights. And there were many more tasks it could do. So these were some project updates. So here you can see we made the robot hand, and then we attached it. Yeah. So the aim was to combine all these things. So this was a progress presentation, and this was the final thesis that we submitted. So it had all the information about it. Yeah, so this was the complete model where the face was a model properly in a 3D CAD software. We had both the arms, and in ROS we simulated it. So this was when COVID struck, and that was the reason we were not able to fully functionalize it on the real hardware robot, but we presented the simulation. So here we had an environment which was similar to what we had in our college, and we did mapping of the environment. I have few photos of that as well. I will show you. And then this was the hardware part, how it worked, and which were the joints that we had. And this was the navigation part. So here you can see it had a complete 3D 360-degree LiDAR. So these red line you can see, these are the readings from the LiDAR. And this white area you can see, it is the depth cloud coming from the depth camera. And this is the view from the camera of the robot. So if I give it a navigation
Uh,
goal over some,
Sorry to disturb,
yes.
but like for me, the screen is just on thank you.
Yeah, yeah.
Oh,
Presentation screen.
For me as well, yeah.
oh, okay. Okay, okay, just a minute. I guess just a minute. I will share it again. Yeah, can you guys see it now?
Yes, yes, yes.
Yeah, I'm sorry. So here you can see we had the complete CAD model. So we had both the arms of Disha. This head was modeled in Fusion 360. This body was modeled in Blender because it could give it more natural curves. And then we attached all the joints one by one. Then this was the arena that we made because we were not able to access the robot in the college because college was in complete shutdown. So we made the complete arena like the actual college in our university. And then this was the mapping part. So we could navigate the robot or manually using a using keyboard of your laptop, and then you can make a map of the surrounding. And then this is the fabrication side. Yeah, there are all the gears that were there. And yeah, so here you can see this red line. So it had a 360-degree LiDAR on board, so it could like check on obstacles in all 360-degree. Then this white square that you can see, it is a depth cloud. So there was a depth camera which was connect on front of the robot, and we can see a depth cloud. So here there is a wall, so that is the reason there is a white straight line. And then this was the uh, RGB image from the camera that was on board. And if I give it a goal somewhere over here, so it could plan a straight path to it, and it started navigating there autonomously. So here you can see this is like the live image that we are getting from the camera. This is the depth cloud. So right now there is no wall in front of it. So there is just the floor. So we can see all the points at the floor. And once it reaches, it will align itself to the goal point that is given. And even if there are any obstacles, it was able to avoid it very flawlessly because it had do I have that? No, I don't have that over here. But yeah, as it has a 360-degree LiDAR, it could recognize obstacles and it could avoid them very easily. And finally, this was the inverse kinematics using move it. So we can give it different states like start state, pickup state, and different states we can give. And based upon that, it could grab objects depending upon what it would like what it would see. So this is how all it went. So
Okay.
I don't have a proper video that I can show it to you because the project is still ongoing by our juniors in the college. But yeah, hopefully it will be ready soon this year, and I will be making all these repositories public because we want more people to work on it. We want it to evolve because currently only the humanoid robots that are available in market are by Hanson Robotics, which is Sophia, and Boston Dynamics, which is Atlas. Both of them are closed source, but there are lots of open source projects, but they are just limited to Arduino without any intelligence into it. So that is the reason we are making this open source really soon. And yeah, if you wish to know when we make it open source, either you can follow me on Instagram or you can follow Rig Builder Labs on Instagram, which is the company that I am running right now, Rig Builder Labs. Yeah. So recently, one of the person who graduated from our training program, he made a waiter robot, which was similar to this. So yeah, so here you can see this waiter robot. So even it could navigate autonomously. So yeah, so here is a detailed video about it. Even it had camera. So it is based on the technology stack that was based out of Disha. So similar kind
Yeah.
of things you can check out on Rigbitter Labs server.
Yeah. Thanks,
Yeah.
Pranshu. I think it's really good that you plan to make it open source so a lot of people can also, start
Yeah.
building this and improving upon this and contribute to this
Yeah.
basically.
Yeah.
So yeah, thanks. I think this was a really cool presentation, and hopefully it will be very helpful to all the people who attended it as well. So now let's have some questions for the next. We have 15 minutes, right? So you can go
Yeah.
ahead with any questions that you have, any specific questions related to the technology used, or how you can start building this thing on your own, or whatever. Like, yeah, we are open to questions now.
So yeah, one more thing I would like to add, the reason behind me showing you all these behind the scenes without a presentation was I wanted to show you that we started from scratch when we were not at all professional. Okay, we don't know anything about robotics, we didn't know anything about computer vision, voice recognition or anything. We just hopped onto it and we kept on figuring things out on our way. So if we can do it, obviously you can do it too. And at that time we didn't had 3D printers, we didn't had internet very Geo become like Geo was introduced in 2017, late 2017. So we didn't even had that fast internet connection speed. We were just staying on 1 GB internet per month. So that
Yeah.
yeah.
Yeah, that's very
So that was one
motivating
thing.
actually. That you just started doing it in the first year itself, and then you stuck with that project and started improving on it, and you learned everything like computer vision, raw, everything along the way.
Yeah,
So this
exactly.
should be inspiring to people as well. Okay, so anyone has any question, or if you also have something to add, you can also just share your views, right?
So like really, Pranshu, it was like a great journey. Like yeah, very very much motivating, and yeah, you did a great job there.
Thank you, Shaurya.
Yeah, thanks, Shaurya, for your input. Um, yeah, do you also have a question, or you just wanted to comment?
No, like no, not a specific question, but like just I want to ask like are you are working on like robot arms and that kind of thing in your company?
Yes, we are. So we are working on these inverse kinematics related robot arms at our company. So we usually develop softwares and simulation for these kind of robots along with the control systems. So we don't directly work on hardware because most of our clients are abroad, based in like foreign countries. That is the reason we don't work on hardware. But yeah, we are also we are planning to make our own robot arm really soon. So even if you want to check that out, you can go and check out Rigbitter Labs mentorship programs as well, because we are starting a robot arm mentorship program. I will just to give me a moment. I will show you a video that will clear things out. Uh, yeah.
Yeah.
Just
Meanwhile, if anyone has other questions, you
yes.
can go ahead.
Yeah. So this is one kind of robot arm that we are working on. So like this is an industrial robot. So if I give it a goal location, it will go there autonomously. So I can change the different positions of it. So if I give it this position, it will plan its path and it will go over there.
Hmm.
So this is something that we are working on, and then this is a smaller version of it. So if I give it a goal, it will go in that orientation.
Yeah,
So
that's
again,
really
this
nice.
was
So you
yeah,
you
this was
so you plan to so you're currently also working on this.
yes, yes. So this is our professional projects that we do. But
Hmm.
yeah, this was just possible because we made Disha, because all these things we implemented in Disha, and that was how we learned.
Ah, yeah, yeah, yeah.
Yeah.
Yes, that was good. Nice.
Yeah, it's also the thing, right? When you do one project, you learn the skills which you can transfer to other projects, right? Similar project or even
Mm.
slightly different ones. So that's really really cool.
Yeah.
And also, you didn't have any ROS experience before, or you did spend some time learning ROS before that, and before you did the project.
No, no. So, like, if you ask me, the first year of Disha was completely manual kind of thing. Most of the things were into mechanical engineering. So we
Hmm.
designed it, we made the hardware ready for it. The second year of Disha was when it had a little bit of AI. So AI in the sense of computer vision, AI in the sense of speech recognition and stuff like that.
Mm-hmm.
Third year was when we started with ROS. So we started about navigation techniques and stuff, and uh, we didn't had any prior experience. We started by just like Ross Wiki was the best place we could start.
Yeah.
And there is one more Indian author named as Lentin Joseph. We referred his books. They are really nice, so you can definitely check it out. So yeah,
Yeah,
using those
definitely.
books,
Hmm.
we were able to make it possible. And in the fourth year, we worked on the robot arm and inverse kinematics. So that is how 4 years of Disha were.
Yeah, yeah, yeah. That's the like. It gives. It can. It should give like a direction or to
Mm.
people on how to proceed. Right. That's.
Yeah.
You just define a project, but also I think one of the points is also that you were really interested in this project, right? You wanted to build this, and that's why you could stick with it. Otherwise, what happens also is that you take a project for the sake of it, and then you are like, yeah, it's okay, but you don't stick with it because it's also like, of course, one of the things that's not visible is that you probably got stuck a lot of times, right, with your wires
Yeah.
burning and stuff like that. So you
Mhm.
have to like the project, otherwise you will probably leave it
Yeah,
along
that's
the way.
true.
Yeah, yeah, yeah.
So yeah, problems are going to come. You have to just learn from it instead of getting sad over it. Just learn from it and move ahead.
Yeah, yeah, yeah.
Nothing is going to be perfect in the first place.
Hmm, 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 hmm. Yeah, that's really cool. So, okay, anyone has any questions to add? I think the presentation was really clear and self-explanatory. That's why we don't have a lot of questions. But if anyone has any questions, or I mean, come on, guys, you have the chance to talk to Pranshu directly, right? Go ahead and ask something if you have. It can also be
And
related to Rig Beetle, or if you're curious about what they are doing. So they also have a Discord server, right? So
yeah. So that Discord server is more like we wanted to spread this. Like right now, a lot of people know about Arduino, they know about Raspberry Pi, but a very few people, few students know about ROS. So that is the reason we created this our Discord server, and most of the things that we put on that Discord server are related to ROS, just because we want to promote ROS based education.
hmm,
So
hmm, hmm,
yeah,
hmm.
because that is what we are using in industry currently. So if you know ROS, you automatically become high level.
Yeah, for sure. Yeah, that's a necessary skill now. Yeah.
Yeah, right.
Okay. Yeah. Then thanks a lot, Pranchu. I think so. Let's have some final words from Pranchu in general of
Yeah.
how it was and what your plans for future are, and before we can wind down.
Yeah. Yeah, so as I explained, like there were 4 years of Disha. First, it was completely mechanical. Second, it was completely computer vision and AI. Third, it was ROS navigation, and fourth, it was ROS manipulation. So currently, it's the fifth year of Disha, and technically sixth because 1 year went down in COVID, but nothing happened in that. But in this year, it's more about cleaning up. So our juniors in the university are working on it. They are making the package more cleaner, more open sourceable, so that people don't get confused when they have the package. So we are
Yeah.
working on the documentation and stuff like that. But yeah, once it is open source, you guys will be able to 3D print all those files, because when we started, we didn't had anything. We didn't had proper CAD designing softwares. We didn't had CAD designing experience, no 3D printers, nothing. We were just making it out of wood. But now everything is accessible, and even if you don't have a 3D printer, you can source it, because there are a lot of 3D printing services available as well right now. So yeah, we are making it so that it is really affordable to make one. You can just consider it is a 5 feet tall robot, and it costs less than 1 lakh rupees to make it. So it's really affordable if you look it from a point of 5 foot tall robot.
Yeah.
If you just look at 1 lakh rupees, it's costly. But yeah, you can get an iPhone for 1 lakh rupees, or you can make a humanoid robot that can work for you in 1 lakh rupees. So you can think about.
Yeah, no,
Yeah.
that makes sense, right? Also, I mean, affordability is a huge factor. Otherwise, these hardware projects are mostly restricted, right, because of the
Yeah.
money involved or
Mhm.
hardware components
Mhm.
involved and so on.
Yeah,
So,
and technically you don't need to even invest that much of amount to get started with all these things. You can simply make a small two-wheel drive robot, and you can have a robot arm on it. A small one, maybe 20-30 centimeters. You can make a small humanoid robot which can do similar things. Only it won't be able to work in real life, but it can do it on a miniature scale. You can use it as a proof of concept to showcase it to somebody.
yeah,
So
to
yeah,
start
so
with, probably you don't need that much. Yeah.
mm, exactly. So I would just encourage you guys to start at least, because taking the first step is the most difficult step. Once you get into this, there is no way out. Okay, once there you get into it, you will find one or the other way to make it possible,
Yeah.
or else you fail. So failing it was never an option. Even I would recommend you not to fail anytime, even if there are road blockages, but you can definitely figure out a way out of it. So just keep on working. When we started it, there were no resources available. There are a lot of resources available at this current moment. Just make proper use of them, and you would be very good to go.
Yeah, perfect. I think that's the best way to conclude it, right?
Yeah.
These are the words that you need to hear. So yeah, thanks a lot, Pranshu, and it was
Yeah.
really a pleasure having you on our server and presenting your really amazing project. And let's keep in
Thank you.
touch. And in the future, if you
Yeah.
need any support from my side, or if you want to present something more, we can of course plan about these things also in the future.